Alright, let's dive into something mind-boggling today. Have you ever stopped to think about what makes up most of the universe? I mean, really think about it. We're talking about dark matter, this invisible, mysterious stuff that scientists believe accounts for about a quarter of the universe's total energy. And yet, despite decades of searching, we still don't know what it actually is. It's like the universe's biggest unsolved mystery, and it's right under our noses, or rather, all around us. Personally, I think what makes this so fascinating is how something so fundamental can remain so elusive. It's like trying to catch a shadow. Now, here's where things get really interesting. A team of researchers from Kyoto University, Hiroshima University, and Neon University decided to take a completely unconventional approach to hunting for dark matter. Instead of relying on lab experiments, they asked themselves, what if we use the entire Earth as a detector? I mean, think about it. Earth's magnetic field is massive, spanning the entire planet. No lab could ever replicate that scale. And that's exactly what they did. They turned our planet into the world's biggest dark matter detector. It's such a bold idea that it almost feels like science fiction. But here's the kicker. The theory they were working with had a major limitation. It could only handle frequencies below 1 Hz, leaving a huge chunk of the spectrum unexplored. So, they had to build an entirely new theoretical framework. What's really cool about this is how they factored in the Earth's atmosphere and its electrical conductivity. This allowed them to predict signals up to 30 Hz, which is a game changer. What many people don't realize is that this kind of innovation isn't just about finding dark matter. It's about pushing the boundaries of what we think is possible in science. Now, let's talk about what they were actually looking for. 2 leading candidates for dark matter are ultralight axions and dark photons. These particles are mind-bogglingly light. We're talking 19 to 21 orders of magnitude lighter than an electron. To put that in perspective, it's like comparing a grain of sand to the size of the Earth. What makes this really interesting is how these particles interact with electromagnetic fields. Axions, for example, are thought to convert into photons in the presence of a magnetic field, while dark photons can generate electromagnetic waves even without one. It's like they're playing by their own rules. The team analyzed a decade's worth of geomagnetic data from the British Geological Survey's Eskdalemuir Observatory. They filtered out artificial noise and searched for the steady, narrow-frequency signals that dark matter should produce. Here's where it gets even more intriguing. They found several signal candidates that could be dark matter, specifically dark photons. And this is a big but we don't know for sure yet. It's like finding a piece of a puzzle but not knowing if it fits into the bigger picture. What this really suggests is that we might be closer than ever to uncovering dark matter's identity. What's truly groundbreaking here is the scale of their approach. By treating the Earth as a giant detector, they set limits on how strongly axions couple to light that are 100 times tighter than previous ground-based experiments. That's insane. It's like going from a magnifying glass to a high-powered telescope. And it's not just about axions, their framework can be applied to dark photons too. If you take a step back and think about it, this isn't just a new way to search for dark matter. It's a new way to think about science itself. But here's the thing. Despite all this progress, dark matter's identity is still a mystery. And that's what makes this field so exciting. Every new discovery raises more questions than answers. Personally, I think that's the beauty of it. Science isn't about finding all the answers. It's about the journey of asking better questions. So, what do you think? Are we on the verge of cracking the dark matter code? Or is the universe just keeping us on our toes? Let me know in the comments below. Until next time, keep looking up, or maybe, in this case, looking around.